Hey all, this is Harini. Welcome back to our YouTube channel Code with Harini. Today we are going to solve July 19 LeetCode challenge, which is remove subfolders from the file system. So what that means, so they have given a list of folders. We have to return the folders after removing all the subfolders in those folders, which means they'll be giving us a list of folders like this, and we have to remove the subfolders, which means we have to just return the root directory. Okay, so if a folder of I is located in another folder J, folder of I, which means let's assume this is the folder of I. Okay, it is located within another folder of J, which means A. This B is located in A, right? So it's called subfolder of it. Now B is a subfolder of A. Okay, so yes, folder of J must start with folder of J, followed by a what will we call slash. Okay, for example, A slash B is a subfolder of A, but B is not subfolder of A, B, C. Still, A, C, B is not subfolder of A, B, C, because either it should have A slash B, but C is a subfolder of A and B in this case. Okay, and B is a subfolder of A. But we can't assume like this B is not a subfolder of this. Okay, I hope this makes sense. So the format of a path is one or more concatenated strings form in the form of slash followed by one or more lowercase English letters. For example, LeetCode and LeetCode slash problems are valid path, while an empty string and slash are not. So what they are telling, so there can be possible will be having empty string and empty slash as well. So that's why they are telling these are valid paths while an empty string and slash are not. I hope the question description makes clear to you guys. Now just take a look at this example. So here they have given slash a b. Okay, now we know we have this B is a folder of already given root folder A, so you can remove this AB. So slash cd, we have cde and cf. Okay, but if you see E is a subfolder of this root folder cd, so you can remove c slash d slash e. CF, we don't have a root folder C in this given input folder, so you can't remove this. So you can straight away have it. So what we are basically checking whether the before for any folder at the end, we'll be checking before folders exist as a root folder or not. If not, just remove this. You just don't append it to the resultant string. I hope this makes sense. So here if you see slash a, so if you see for B and C we have a root folder A already. So ABD we have a root folder A already. Yeah. Even if you have A slash B, still for that A slash B the root folder is A. So we have to have only one top root folder among everything. I hope this makes here if you see slash A B C slash A B C A slash A B D, there is no root folder called A slash B or A. So we can't remove any of the folders. These all subfolders of A, B, but we don't have that root folder, right? So we can't remove any of them. Yeah, I hope this makes sense to you guys. Now just look into the visual representation, how this works and how we are going to approach. Yeah. Okay, now let's take this example. What is folders contains root folder A, B, C, D, A, B, C, C, D, and CF. Why I have given in the mixed order? In the sense, if we have seen in the example, they have mentioned like we will always have. They have mentioned like they will be giving a folder structure, but they have never mentioned it will be always in an order, so it can be mix and match as well. So what will be our resultant root folders? So if you take the root folders here, what will be, so if you just see A slash B, we have this root folder, right? So we will be taking A. For A we don't have any root folder, so we won't. it's just a single directory, right? So we won't. So next what we will be doing, we will not take this AB because already we have found this in a root folder. So D, we have to check in. Okay, before CD, do we have any root folder called C in any of the example? No. So we will be taking CD as well. Okay, next comes ABC. So if you see AB also there, ABC also there, but we have to take the topmost root, which is A, which is already there, so we won't take this as well. So C/D/E, CD is already there, so we won't take. But for CF, do we have a folder called C? No. So CF is also a separate root folder because we don't have any top folder called C where you can just take that root folder and ignore this. But no, we don't have any folder called C. Now we won't miss any of the folders. Under this folder you will have ABC. Under this folder you will have CD as well as CD as well. Under CF you will get. So by this, it's not like we will miss any folder. By root folder means if you go to this, you should have all the folders, anything that should not get missed. So since if C was there, let's assume if you have a call C, so we don't need to have this. Instead, what we will have straight away, we will have only C folder. So under C you will have CD, CDE, CF, everything. Under A we will have AB, ABC, everything. So that's what they have mentioned what we need to return. Okay, now hope this makes sense. Now just look in solution. What are the different possible solution that we can try and how we are going to optimize it. So as I said, so they have never mentioned all this will be unique as well. There can be a same set of strings that might exist. So for the first approach one, what we are going to do, we are going to keep on checking whether this for this AB, first we will be checking whether A was there in the, if not we will be check because last will be the subfolder, so we can ignore the last. So if you ignore that, what we are getting empty string for this. So we for this we will be checking after we ignore, we'll have A, right? We'll be checking do we have any A's. Yeah, obviously we have. Then this is a subfolder of some folder that exists in the array. So there can be a possible that we will have repeating same slash a might be also there. So to avoid that, what we are going to do, we are just going to do a set of this folders. Now what I'm going to do, folders, a set I'm going to create, which is nothing but set of folders. So we'll be getting the folders as an input as we have mentioned. Okay, set of folders. Once I have done set of folders, what I'm going to do now I have to keep on traversing through the, now I am having my root folders as a empty array. Now what I'm going to do, I'll be going for each folder in folder set. So what we are going, first this is not a subfolder, we'll assume, right? So based on the condition whether the subfolder exists or not, we will be updating. And now I am assuming this is the prefix folder. Okay, so while prefix not equals to empty string, because what we are going to do is matters. So we at the last will be the subfolder, last will be the folder, so under which we will have that we will be have to separate with the rightmost string. So what we are going to do is we have to find position of the rightmost prefix. So in Python we'll have r find of whatever the character you are giving, it will give us the position of this. For example here 0 1 2 3, it will give you 2. So now how we want to, we don't want this till 2, we want only till, we want 0 till 1 character. So what I'm going to do, if that position is not equals to -1, so if equals to -1, okay, now we can't find anything, right? If position equals to -1, so we are not finding anything, so we just breaking. For example, for this string, okay, if you would have taken prefix dot r find, what we would have got, we would have got 0, right? So there might be some case we will be getting empty string. For that, what will be our position? So something like this will okay, I'll come to that point later. Now position equals to -1, so we are breaking it. Now we will be updating our prefix. Tell this position was our folder now, and we'll be checking this folder exists in any of the case. So prefix equals to uh, prefix till 0 to position, which means the slash would have cut. We would have got the, yeah, if you have got 2, 0 to 2, which means 0 1 till 1 only, we will be updating the value. Okay, now once we have got that prefix, what we will be checking, if prefix in folder set for his, then his subfolder is true. Yeah, obviously slash a is exists right in the folder set. So okay, subfolder exists means that we don't need to do anything, straight away break. Then after this while loop, if not subfolder, what we will be doing, we'll be appending to the root folder, right? Yeah, this is our root folder, so we will be appending to the folder. I hope this makes sense. Then at the end we'll be returning the root folders, correct? Okay, so this is how it works. So now, okay, for a slash b I have told. Now let's take this example. Now our root folder would have slash a, because first our root folder, now first prefix will be slash a. So we are finding r find, which gives you the position 0. Now the prefix would have gone to till position 0, you have to append. Okay, something till 0. Already 0 star 0. So there will be no character, prefix will become empty. Right? But does empty is in any of the folder? No. So prefix will become empty. So it's not a subfolder. So when while loop goes here, then prefix got empty and the root folder got appended to slash a. So the second will be slash, let's take a slash a slash b will be our prefix. Now where we would have found this here 0, if you take the 0 1 2 3, our position would have got 2, right? So position is not equals to -1. So 0 to 2, what will be our prefix now got updated to slash a, right? Slash a is present in the subfolder set. Yes, obviously we have. So it is a not a root folder. So subfolder equals to 2 and we are getting break and we are not going to append because it's not as, if not subfolder only we have, but ours is a subfolder, right? Yeah, so we will not be appending that. Okay, next when comes a slash b slash c as well. So now we'll be checking. So when this comes slash c prefix, our first position will be 3 4 5. Position we would have got as 4. Right now if you break 0 to 4, 0 1 2 3 we will be having, so prefix would have got updated to 0 1 2 3. Now prefix in folder set, why we are not checking in root folders, because we should check in folder set. For this itself we already updated this as a root folder. Again if abc comes also, we have these two root folders, but we have to append only the top root folder. So we will be checking whether this a slash b is in folder set. then obviously you won't append this as well again subfolder equals to 1b, and we are updating the root folder. The same way it will work for all the cases. I hope this example makes sense to you guys how it works. Okay, now let's look into the time complexity. So if you take the time complexity for this, already we are putting set. Each set of folders will have n words and the length of each word, right? So then after that what we are doing, again we are calculating for each n. Okay, we will be traversing through for each n. Okay, for folder set will have again n, right? So for each n what we are going to do, we are again traversing through the l length to figure out, to find out the index itself already n, which index it is. Okay, to traverse through, and we'll be finding the last r, and will already traverse through the length l, right? And again after that we will be updating till that again it will go l. So for each l again it is going l, and it is comparing the l square. Okay, so that's how. So again it will traverse through l square here. So in turn what is our estimated time complexity is n into l square. So space complexity is obviously n into n. We are just storing the folder root. To the max all can be root folder, so we are storing the root folders, right? So we are taking it as a n l. Now how we can further optimize this? So now if you see, now we have to keep on traversing through the prefix, and we have to figure it out what in where this root can be exist, something like. But if it is in a sorted way, sorted, okay, then we can, it will be always whether the previous root folder, for example, even in this case, if it was sorted, okay. Now let's take a look at that. If it was ordered, how it easy for us to do the same things. That will be our approach. Now it is approach 2. So approach 2 is nothing but what our folder structure will be in a sorted order. That's what we are going to do. So slash a slash b slash c slash a b c, because it will be, see, if it has something started with c, then it will sort with the next letters, right? So yeah, next cd, cf, then cde will be, yeah, sorry, that's my bad. Yeah, because cd, then it will go for same cde, then CF. Welcome. So like this it would have sorted already. So you just check the whether the previous you just append this previous value, you just append one slash, whether this starts, previous starts with uh, for this particular string, the previous value is previous root folder is starting with the current node, then obviously yes, then you will be checking this ab, then you won't be appending this, right, because it's a subfolder. Now then again for slash abc you will be checking, okay, the slash a is starting of this, then okay, then root folder is there, then we won't be adding this. Then here comes cd, so we will be appending one cd slash, okay, this is starting with this only, then we won't append this. But then if you would have added cd into the array, but cf for cd is starting here, no, right? So cf also will get appended, so whatever the resultant array we want we'll be getting just by accessing the last root folder of last value, correct? So how the code will be working? So folders dot sort, we have already sorted. Now we will be checking the same root folders we will have as a empty, not empty, whatever the first was there, that will be our for sure, it will be the root folder, right? So we'll be taking that. Okay, now what we are going to do, we'll be traversing through for I in range. Now we'll be traversing through 1 till length of folders, right? Now we'll be checking last node, what is our last folder equals to last root folder of -1, which will always give us last. So just we are appending slash to it. So now the A will be, last folder will be like this. Now we'll be checking if not folder of I dot starts with our last folder. So if not, then obviously that is not a root node, that is the root, right? So root folders dot append. There is no need of extra variable as a subfolder or not. That's why we are doing. If not here, so you have appended. Now just return the root folder. You guys understood, right, how it works? Okay, let's take a look. See, last folder is -a. So my next I will be starting from 1. Our current folder of I is A, B. Right now we would have got last folders. This starts with this only, right? Though, so it's not a root folder, so we won't be updating the root folders. Understood? Now let's take next example, /abc. So now what, the same root folder, last folder is same, /a. We are going to append one slash at the back. So now we are going to see /abc is a starts with this /a. Yes, absolutely. So this is also not a root folder. Next, here comes slash. Next, I will be /cd. Is it starting? No. So now we will be updating c/d. Next, cde will come. Right now, cd and the same starts with anyway. That again it will work. So there is no issue. We should always need to append. Okay, now cd starts with last folder of I. Yes, so don't append this also. So next the same cd exists. Now our case comes cf. Okay, is it starting with cd? No, so we can append the cf. I hope this makes sense how the sorting and because it will sort on based on the length as well as based on the characters. If it is of same length, then it will sort based on the character cd and cf. So here cd comes first, right? Even though the length is 3, cd comes, so this will be in the sorting order like this. Okay, now we would have returned our root folders. Now for the sorting itself will be like n l log n, because l is the length of each letter. Okay, n star n log n we would have taken. Again we are traversing order of n and length of each characters to check the starts with, but still it over time complexity will be n log n l log n. Okay, the same space complexity will be n into l to store our root folders. Okay, I hope this makes sense. Now how we can optimize this login. Now just take a look at that. Okay, now that will be our approach 3. So instead of checking starts with every time that will traverse through all the node, why we can't see this all forms like this, right? A slash, so A children node will be B children node will be C. Like this, if we form a tree, okay, C something called root exists, so that as A C will give us D will give us E, and the same C will give us F. So if so here what we are trying to say, so when we will be doing like this and we'll have a one variable called ends with. Okay, if you have the ends with, when you are traversing A equals to your ends with will be setting to true. So again AB ends with would have set to true. So ends with, we'll have another variable called ends with will have set to true. So like this will be setting, but C we won't have ends with set to true because there is no false. So CD ends with will be true. This ends with will be true. Like this will be whenever you're creating a node, you have a value as well as the next children for that if you have. If not, have ends with variable. So what we'll be doing, we'll be creating a trie structure like this. Okay, root all this A B. Again, when first we would have got A and we would have written ends with equals to true. Then we would have got A B. Then already like this A B. So we will be checking whether A is already exist. If not, go to the next node. Then if B exists, no. Then create the children of the A with B. Okay, then checking this is the last node. If so, update with true. If not, then again A becomes A B already exists and for but C wasn't. So like this we would have created all these nodes. Once we have created the nodes, what we are going to do is we are going to traverse. So what we are going to do, we'll be starting from the path same slash A. We will be checking, we will be iterating through this folders. This is the path, these are the paths we have got, right? We'll be iterating through each folder. We'll be splitting based on the slash. So now first we would have got A for this, right? Then if it is not empty, then we will be checking, we will be getting the current node for this. First, let's assume we are giving a root, okay, that has nothing, that is having all the children. So those children is A. So we will be having a root initially. That root will have sign children like this A B. Again that A will have, and what we will be having A B. Okay, B has children, again that is children, and another variable ends with is true, and B has C. So like this, so it's a kind of trie structure. Hope this makes sense to you guys how it works. So now we have given a current node as a root. Now we will be checking, we would have got A, right? Okay, now I'm checking the current node of A. Okay, this is the next node for the root, right? So when the next node is come, is it ending for then? And it should not be the if it is ends with, and if it's not end of the for path, which means okay, this is not a root folder. Okay, for example, if it comes here, okay, they would have split into A and B, but when we are traversing here itself, we would have got ends with it's the end of the folder. Some folder exists already with A itself, so then it is a subfolder, right? So then we will be giving, if it is a subfolder, then there is no need of checking further, then you just return. Next we will be going ABC. Like this we will be checking based on if the ends with of any of the path, uh, for this, for any every example we will be getting like this ABC. We will be removing the split, and we would have created a trie structure. Okay, and will have ends with variable. When it ends with, that should be the end of the array, which means there is no root folder for this. If it's not end of the array, for here A itself have some other root folder, so that ends with will be set to true, which means for this example, when A comes itself, we know okay, ends with we have the variable called end of the folder. Already we have one root folder for this, so we do it now. Whatever we are traversing is a subfolder for this. So what we will be doing, we will be just returning, we'll be just setting a subfolder is equals to true, and we'll be just returning that array. I hope this makes sense to you guys. Now how this try going to work, right? So now just take a look at the approach 3. Try structure. We are going to create a class try node. Whenever you are creating the try node, I just told we'll have a JSON structure, and self dot is end of folder will be setting to false initially, and will be setting the children for them as a empty JSON. Okay, so next, so whenever this method is getting called, the def remove subfolders. The class solution, whenever we are getting created, which they would have given, right? The solution, whatever the given class, maybe here they have given class solution. So whenever this is getting created, I'm just assigning a root which has a try, which will call this try node. Okay. So I will have a root initially when this class got created. Now they will be calling the remove subfolders. As I mentioned, we will have self comma folders. Okay, this is the remove subfolder. Now what we are going to do, we are going to traverse whatever the folder. Let's assume I am having a path in folder, each folder, which means, for example, you know, slash a slash ab slash cd slash cd e, then a b c comma c f. This is the example that we have taken, right? So now this all called path. Now what we are going to do, we are going to split. So current node equals to self dot root. Okay, this is what we are going to do. So folders, we are going to do path dot split slash. So now for this, what I would have got A. Folders will have A. So now what you are going to do, for folder name in folders, this as well be the each folder name in the array, right? So now what we are going to do, each folder name, if folder name is empty, there might be a case where they can give empty string as well. Okay, so if a folder name equals to empty, you don't need to do, because that's, we won't take anything, right? So the same, if folder name not in current node dot children, which means, okay, thus A is, now the try is empty, right? I'm having this as a try is empty now. Okay, it doesn't have any children, it has an empty children, right? It's not in current folder as well. So what you are going to do, we'll be appending current node of folder name. I'm going to create a try node. So the current node dot children here, because we are going to append every time to the children, right? Now it has a something, you just assume it as a root. Okay, now for this root has try node, which means for current children, this root children, what is the folder name that we are going to do, which is A. So A in turn now will have one more try node. Okay, yeah. Now we have created this. Now again when comes AB, so what will be our folders, will be A comma B, right? So when A comma B comes, this is the root and this root has this. So initially when A comes, we have given the self dot root, right? Self root, which means this. Now folder name will be initially A. Folder name is not in folder name, not in current node dot children, it has. So we won't be appending A again. Now when B comes, okay, now the current node we will be giving as current node equals to current node of children, because children of whatever the folder name. Now the current node will be A. This is what we are giving as a current node now. Now when A comes, we'll be checking whether B is also exists. Now folder name would have got to be current, it's folder name not in current node dot children. This children is empty. So what we will be doing, we will be now creating B for this. Now I have a B with empty. Understood? Yes. Now again CD comes. What we will be when CD comes, we will be removing this, and we would have appended C comma D by so now again it goes to the root node. So it's checking C is in the children of root, no, right? So what we will be doing, we will be updating C with empty node. Okay, now the root has this A as a children and C as a children, correct? Okay, now again D comes. D is children of C, no. What we will be doing again, we will be creating a try node with D. Got it? Okay, so now A, B we have. Next we'll have C, D, E. The same, when C, D, E comes, C, we have a current node, we have D as well for the children of C. Then D comes as a current node. when E will be the folder name, E in folders, folder name not in the current node of children, D as a empty children. So what we will be doing now, we will be creating a D with the children, E with empty node. Okay, this is how the structure works. So now we have got, now again when ABC comes, we already have AB, right? So here ABC will be there. So here if you just check, ABC is already there. So A when comes, root has children A. So again when A goes as a root current node, then we'll be having folder name as a B. So current B, A dot children has B already, so will not happen. Then we'll be just updating the current node to current node children of folder name, which is current node is A dot children is this, of folder name is B. Now I want B children. B is the current node, correct? Now why we are doing dot children of folder name, because it can have multiple children. Now for example root have A, B. So that's what we are doing. Children of folder name will give that respective children. Okay, I hope that makes sense. Then when it comes C in folder, whether C is present in B children, no, B is empty. So now what we will be doing, we will be updating this to, again we will be having C with empty trie node. Okay, trie node will initially creates a empty array, and hope this makes sense. Now that's it. Again CF will come. So again CF when it comes here, initially C will be coming. So we'll be checking C in current node dot children. Current node is root children has C, yes. So now we'll just update to current node dot children of C. So we will be getting this are the children. So next will be coming F in folders. Then we'll be getting F. F is not in current node dot children. We have only current node dot children. So we have only D. We don't have F. So what we will be doing, current node dot children. So we will be updating F also with empty trie node. Okay, now this is how our trie structure will be getting created. I hope this makes sense to you guys. Now we have to just, for A, B, C we have to append A. For C, D, E we have to, for C, D, E, for C, D, E wherever comes we have to update to C, D and C, D, C, F. So like it has a single structure, but here it deviates to the 2, right? Now again we have, after once the trie got created like this node, till this folder name whatever you have updated, so you should update the current node after once you have traversed all the folders. For CF, for A, B, whatever current node is end of the folder, we have to set it to true. By that only we'll know, okay, what is the root folder. Okay, so A would have got end of the folder set to true. So AB also would have got end of the folder set to true. C also would have got, but C wouldn't have set to end of the folder because it has CD only. So CD, CDE, EF. So C is not a root folder. So I have just mentioned here E, which means these are the set to. I have mentioned here E, which means those are ending with those end of folder are set to true. Once we have traversed all folders, which means A, B, C, D, at the end, which this is the end of the folder, right? That node we should have set it to true. By this we'll calculate which is the root folder, right? So now just take a look at that. Now we'll have root folders as empty. Okay, the same we will be the same logic will be having here for path in folders. We'll be having current node equals to self dot root folders. Will be having path dot split. The same will be splitting based on the slash. So now whether it is subfolder, initially it will be false, right? So now what we are going to do, we will be checking for each folders, we will be checking for I comma folder name. I'll just tell why we need I in enumerate folders. Okay, since it has very congested space, I'll be moving this towards right. Now you know, right, how this tree is getting generated. Okay, now just for this, I have just removed the how we are generating this tree structure code, because so that it will be convenient for me to write in the same page. So now what we are going to do, now we have traversed, we are going to enumerate through the folders. Now we have this trie structure already, right? Now we have this trie structure already. So what we will be doing here, the same, if we'll be checking if folder name equals to empty, just then we don't want to do anything, we'll be just doing the continue. There might be a case where we will have empty slash as well. In that case we'll be getting empty array, right? Okay, now what we will be doing, we want next node. What is the next node for this root? A, C. How we will be getting next node? Current node dot children of that folder name, right? Folder name initially. For this we will be having initially folders will be having A. So now the next node is A, right? Now we will be checking if next node is the end of the folder also, and I not equals to length of folders -1, which means for this case it is end. Length of the folders is 1, I is 0, so which means it's already end of the array, then it is full array itself a root only. So this can't be a subfolder. Okay, it has traversed through full array. Okay, is end of the folder only, but it is full array itself. There is no, for example, if you take AB, let's assume I equals to till 1, we would have got that will be AB. B is the end of the folder and it reaches the end, which means there is no previous root folder exists. If it would have exist, it would have returned before itself, right? Yeah, that's what we meant here. So is subfolder equals to true, then you can just break. So if not, you can continue. So if not subfolder, what we will be doing, we'll be appending it to the root folder, right? So root folders dot append path. Oh, I hope this makes clear to you guys how it works. Now in turn we'll be returning root folder. Now for first we will be appending the root folders as A, because we have traversed till end of the array. So there is no, we are appending this path. Okay, there is no previous root folder exists for this particular A. There is no folder exists, root folder exists for this. So next we will be having AB. I equals to 0 initially. Folder name, the next for what we will be getting initially A. Right? Children of folder name is half I equals to folder name is A. Right? Children of A will be getting F. Next node is end of the folder and I equals to 0, which the length of the folder is 2 and length I is not equals to 1, right? So which means for this A remaining we have a subfolder. So a subfolder is to break, but if not subfolder, no, so you won't be appending AB. Understood? Yeah. Next our example comes as CD. Right, we are splitting. Now I equals to 0. For next node will be getting current node root of C, will be getting this. So next node is end of the folder. No, already it's not the end of the folder, right? So then will be going D. D will come. I equals to 1 now. So folder name is D. So next node of D, so C, so sorry, D will be, it will return this E as an next node. So next node is end of the folder. Yes, and it is equal to length of folder minus 1, because I equals to 1, length of the folder is 2 minus 1 is 1. So this is also not a subfolder. So if not subfolder, root folder dot append path. Now CD will also get appended. Okay. The same way when AB comes, now when it is AB. So this is A and this is B. So I equals to 0. A next node of current node dot return will give us A. Okay, this when it gives, the next node is end of the folder. Okay, A is a root folder of something. So for obviously B, so then what it's a subfolder is equals to true and it is not 0 is not equal to 1. I equals to 0, no, which is not equal to length of the folder minus 1. So basically length of the folder is 2, I can go till 1, right? So that's why length of folder minus 1, 0 not equals to 1, which means it's not the end of the folders list. So obviously its subfolder is true. Then we won't be appending AB. So then CDE comes. Let's assume till C D goes. So our loop will be CD. CDE. I equals to 0. Initially goes C. So current node of children, this is it end of the folder? No. So then we'll go to D. So then I equals to I equals to 1. Then here comes D. So D next node, obviously D is the next node, right? So is it end of the folder? Yeah, something already exists with end of the folder C/D. Correct. And this I is not equals to length of the folder minus 1 because E exists. Currently we are passed till D. It's not end. So already CD exists. So which means this is not a root folder. This is subfolder equals to true. Then we won't be appending CDE. So the same for ABC. It will go till A itself. It will figure it out. It's the end of the folder because already something exists, so it won't get added. So for CF, Okay, now initially I equals to 0 and C will be coming here. So folder name equals to now it is C. C children of root is C. So children of folder name C we have to get, right? So current node is C. Current node will be root. Okay. So current node dot children is A and C. We will be getting C, and we will be checking this C is the next node. So next node is end of the folder. No, right? So what we will be doing? We will be setting this. So we will be going to the next. I equals to 1. Now it is F. So current node dot children. Current node is C. C of F we want. So F is the next node. Okay. So next node is end of the folder, obviously, but another case also exists. It is not, it is end of the array as well. So I equal to length of folder minus 1. Right, because I equals to 1, length of folder minus 1 also equal to 1, which means there is no previous root node exist. So subfolder won't get set to true, then root folders dot append path, which will append as CF as well. I hope this makes clear. Here we are just traversing n cross L. Time complexity will be n cross L 2 times. For first forming Trie structure once, then appending to the root will be again traversing n cross L. So which is typically n and L. N is nothing but length of the folder. L is nothing but the number of words. Okay, space complexity storing n cross L root folders. I hope I have given enough explanation. This is the same 3 approaches I have used to solve the problem. I'll be giving those solution in the GitHub link. Please do check out. If you do like my video, please do like, share to your friends. That will keep me motivated to do more videos daily. Yeah, thanks for watching.